So the second gas we look at now is hydrogen. Hydrogen's a little bit different to the other gases in this topic in that it's not actually that common a gas in the atmosphere around us. So whilst nitrogen, carbon dioxide and oxygen are quite commonly found, hydrogen's not really found. We'll look at why that is in a second. But it is quite an important gas in chemistry in general. First thing to touch on maybe, which might be quite interesting, is where it gets its name from. Hydrogen is actually two words pushed together, hydro and gen. Hydro means water, and gen comes from like the same root as generate, means maker. So hydrogen was called hydrogen because it makes water. Because if you take hydrogen and burn it in oxygen, you will make water vapour. And if you think about it, that's actually what you do in the squeaky pop test. In the squeaky pop test, you are burning hydrogen with a lead splint in oxygen. That causes a mini explosion, and the product of that reaction is water. So the scientists who discovered this process thought, this gas makes water when you burn it in oxygen. Let's call it water maker. It's formed as H2, so it's another diatomic gas. And in terms of how you make it in the lab, we normally make it from the reaction we've looked at earlier on in year 11. We know that when you react a metal with an acid, you make a salt plus hydrogen, and that actually is the most effective way in a small scale. So obviously if you're trying to make it in a larger scale, probably not the best, but in terms of making a wee bit in the lab, that's the easiest way to make some hydrogen. You have to be a wee bit careful which metal you pick. Obviously if you pick a metal which is a bit too reactive, it's going to be a bit uncontrollable, and if you pick a metal that's too unreactive, it's going to be too slow. The metal that they kind of settle on is zinc. Zinc's kind of in the middle of the reactivity series. So it's going to produce a good amount of hydrogen, but not too quickly and not too slowly. So the official way you're asked to learn how you make hydrogen is zinc reacting with hydrochloric acid in a container. So just make that kind of consistent. This label here needs to turn to hydrochloric acid. In terms of the apparatus you use, it looks a little bit complicated. We've touched on this a little bit already in the reactivity series. We've seen this kind of apparatus before. In chemistry, whenever you're trying to trap a gas you're making, to see if it is actually the gas you're expecting, you do a test on it. We use a technique called downward displacement of water. So breaking that up, downward displacement means you're pushing water downwards. So how this works is, again, it's hard to see until we actually see it in real life in the lab. You've got your reaction going on here. So here's the zinc. You've poured some dilute hydrochloric acid on top of it. That's going to make hydrogen gas, so bubbles of gas. They're going to fizz away up here. And the only way they can get out is by going down this side of the flask and down this, which we call the delivery tube, which delivers gases. It goes down to the delivery tube and it goes into this underwater section. So this is a glass trough. Inside it we've got a beehive shelf, and on top of it we've got a gas jar. The gas jar has been pre-filled with water, so at the start it was actually filled right up to the very top there. And what will happen here, as the gas bubbles down, gas is quite light, so it wants to rise, and it's going to rise up to the top of this gas jar. Once it gets there, it's going to take up some space, and it's going to gradually start pushing down the water level of what's inside the gas jar. And at the end of the experiment, there'll be no water in this jar, but entirely gas, and hopefully just pure hydrogen gas here. So it's a very neat method of trapping any gas you're making in an experiment quite easily. It's called downward displacement of water. So if we were doing it in the lab, that's how we'd make hydrogen and trap it. Onto the physical properties, kind of very similar to nitrogen in many senses. It's another colourless, odourless gas. It's very, very light, and that is the reason it's actually the lightest gas in the universe. That's the reason you really find it in the atmosphere. If you make any hydrogen in any kind of process, it's going to reach space before you know it. It's going to rise up to all the gases in the atmosphere and get to the top. That actually has found uses throughout history. You might recognise this picture. This was a disaster in the early 1900s called the Hindenburg disaster. What they were trying to develop was airships as a mode of air transport. Obviously airplanes become quite used to now as a very efficient way of transport. It takes a lot of energy though, because you're trying to get a very heavy airplane up into air. The advantage of airships when they made them was that they're very, very light. This was actually filled with hydrogen, one of the lightest gases. So if you've got a very buoyant, light thing, it takes much less energy to get actually moved through air. So it's a lot more energy efficient as a process to move people. However, the problem was hydrogen, this thing was completely filled with hydrogen, very, very flammable. So when it kind of collided with this docking station here in America, it caused a spark, which caused the whole thing to explode. And from that point, they kind of gave up on using hydrogen in these airships. So it's very light air, or very light gas, and it's much less dense than air. Again, it's insoluble in water, so you won't get to dissolve in water. That's why we can actually use this technique to bubble it through water. And it's also neutral because it doesn't dissolve in water. The test actually proves you've got hydrogen gas. Again, we've seen it before. You use a lit splint, you get a squeaky pop, and that proves you actually have got hydrogen. You're making water vapour in this reaction here. It's a mini explosion. In terms of the uses that what we actually use pure hydrogen for, it's got a few uses in society. First one is it's used to fill meteorological balloons at slight. You might not have heard of meteorological balloons. They're sometimes called weather balloons, and that's how you get all that information for weather forecasting about pressure and like air movements and stuff like that. What they get is these balloons here. This is a picture of an actual weather balloon. It's filled with hydrogen, so it's very, very light. So it floats up very to the very high parts of the atmosphere. And it's got a lot of sensors in the bottom. So those sensors will take readings of the air that it's in and feed those back to a satellite. You might think, hold on, but to me say that hydrogen's not very good for making like balloons and airships and things like that. Yes, this could pop, it could go on fire, but because it's just got some sensors in the bottom, we're not too worried about that. No one's going to die if this balloon pops or explodes. So it's quite a cheap, efficient way of getting weather balloons up into the atmosphere. Second kind of unusual use is hardening of oils. Margarine, as you maybe know, it's not real butter. It's actually based on oil, so you make kind of margarine out of olive oil. Olive oil is a liquid, margarine's a solid. How you get that to transition, so how you turn olive oil into margarine, is you harden it with hydrogen. Basically, if you add hydrogen to an oil, it turns it into a solid form. We'll not worry about that for now. We cover it actually in organic chemistry, which is another topic later on, but that's one use of hydrogen. The third one's quite interesting, it's quite topical. Hydrogen could actually be used as a good fuel. We looked at the fact it's quite explosive, and if we're able to harness that explosion in kind of a controlled manner, it's going to produce a lot of energy. This is actually already used in rocket fuel. So rocket fuel is actually a mixture of liquid hydrogen and liquid oxygen reacting together to make a huge amount of heat and force and energy. Obviously, that's very good for rockets. What would be quite good if we were able to use it in cars? So there's a lot of kind of development going on with car companies to make hydrogen-powered cars. We're not quite there yet, but I do think in a few years' time we could see that becoming more mainstream, having hydrogen fuel cell cars. In terms of why you might want to do that, there's actually a couple of good reasons why hydrogen cars seem like the future. One very, very important reason is this. If you look at the reaction of hydrogen to make water vapour, that's actually what the reaction is in a hydrogen fuel cell. So you're combining these two things. You're basically exploding hydrogen and oxygen to make water vapour. That produces a lot of energy. The byproduct of this process is only water. You're not making any carbon dioxide, any greenhouse gases. So if you're only making water, that's a very clean, environmentally friendly form of making energy. There's no kind of trade-off for the environment of global warming. In terms of where you get hydrogen from, you can make hydrogen from a process called electrolysis, where basically you use electricity to split up water to make it into hydrogen and oxygen. So it could be made renewable if you're getting that energy from like solar power or wind power. So it could be a renewable way of making energy. And we are kind of getting to the point where we can store and supply hydrogen quite consistently. So our technology is improving in how we store it. The reason we're not there yet is for a number of disadvantages which we still have to solve. Probably the most important one is it's a very dangerous flammable gas. So in other words, the idea, if you've got a hydrogen car and you crash it, there is still quite a high chance it's going to explode into this big horrible fireball. So we need to make sure we've got a very safe way to transport and store it. The second one is that in the form we are in now, you could still cause pollution by burning hydrogen. Not in this process itself, it's the way we get hydrogen can cause pollution. Most hydrogen you actually get is from burning methane, and in that process you actually do make carbon dioxide. So whilst we can make hydrogen through this renewable electrolysis process, we're not there yet. The current process does actually make carbon dioxide to make hydrogen, so that needs to be improved first of all. The other point is it's quite expensive to store hydrogen in fuel cells. Obviously, it's very light gas, it's very hard to trap, so it's actually quite expensive, the containers you have to use to store it, so that needs to be developed a bit further still. And also, the cells used in cars are actually quite expensive to use. So we think it's the future. We think we will probably have hydrogen cars in a few years from now, but we're not quite there yet. And you just have to know a few wee advantages and disadvantages of hydrogen as a fuel and why we might use it in the future.